Ladies and gentlemen, good evening. Tonight we're going to look at Spring Boot and the Google Vertex endpoints. How do we create a connection from Spring Boot and to the Google Vertex endpoint, and then get a result? We want to predict some images, but we want to use an image classifier, which I've shown you in other videos how to use that. So go a couple of videos back if you want to see exactly how it's done. I will fast forward right now, and actually not fast forward. I will tell you just quickly. I'll summarize what we actually did in the other video. So we created something called a data set right here. So first of all, of course, we're using the Google Cloud. We went to Vertex and we enabled a lot of services. Then we went to data set right here, and then we created a new data set. Inside this data set, I went out with my phone, and then I took 88 pictures with different categories. Some of them were rocks, some of them were grass, some of them were dandelions, and then there was also some signs and some markers. So we have these categories right here. Afterwards, then I went and created my own model. I did not create my own model. I reused an existing model, but I trained the model against these categories and with these images. So I made this training model right here, which is based on the AutoML model, which is something you can just pick up from the shelf, free to use. Of course, it costs you money to use anything. And everything in Google Cloud, and especially with AI, it can cost a lot. So be careful, especially if you deploy something as an endpoint. Then you will actually pay for that. You will pay for that, even though that you're not using it at all. I actually went into that situation, so I got a larger bill because of that. Even though I did not use the endpoint, I thought it was just like with the other most of the Google Cloud products, that you have to use them before they actually cost something, and then it usually cost per traffic and something like that. But that's not. Be very careful with the Vertex, with everything actually in the Vertex. If you have something that is live or has been created, then delete it if you don't need it, because it costs. It can cost you a lot. Of course, you can see it on the billing page, and you can also see it on the billing page. And of course, if you read about pricing in Vertex, then you will also figure this one out. I did not do that to begin with. Of course, I should have done that. But that's how it is. So training right here, I trained it, and then I after 1.5 hours, something like that, then the training was done, and then I published the model, the trained version. I published that as an endpoint. And the confusion matrix is right here, so it's actually quite good. Even though I only took 88 pictures, it's only dandelion, which sometimes is being mistaken for grass instead of dandelions, which is okay because there's a lot of grass also on those images. So let's go to online prediction right here. So this is where I have my endpoint, and if you want to know the basic stuff about how to connect to this endpoint and how to use it, then you just press sample request, because then you get a curl. You get a curl example right here. So there's a curl example. You can also press Python, then you get a Python example instead. So you have Python, and you have the curl example right there. So I actually took the curl example. If we look at the curl example to begin with right here, I took the curl example and then I converted it to Java actually. So we can see here there's a header where we need to have the authorization. So there's a header right there. Let me just show again. Here we have the header. There's a bearer, and then there's a token, the usual Google Cloud token. And the Google Cloud token can be fetched with a library for Spring Boot. So we need that one, and I'll show you how to do that. Then we need to say that the content is JSON, and then we need to post the data in this format right here: instances, content, and then parameters and confidence threshold, etc., and max predictions right here. So that is what we need to do. And how do we do that? It's quite simple when you know how to do it, but if you do not know how to do it, then it can be a bit difficult. So I'm using Gradle right here. This is a Spring Boot project, so I pressed File, New. New projects right here. Then I chose Spring Boot, and I chose, I think it's just running Java 17 actually right now. I'm using JDK 22, but it's compliant with 17. I chose jar, not wars, and then I selected the web. I selected the data just for fun. I'm actually not using that in this demo right here. Then I used H2 because then I have a memory database. Then I added, did I add more stuff? Yeah, Lombok. Oh, I was at Lombok. So I also had Lombok. And that's it. Then I ended up with this project right here. Then I added some dependencies manually, and that is because if you want to get that token that we just talked about, then there's a cool library named Google Auth Library Credentials right here. And this is version 0.20. I don't know if there's probably a newer one out there, but that's the one that I took. Then I also need to import Auth 2 HTTP, and again version 0.20. And those two, if you import these two, then it's quite easy to get the token, and I'll show you how. What actually happens is that that the default authentication, so that means that when you write gcloud with your CLI tool, when you go to a terminal and then you log in with your gcloud auth login, then you have that is called your default authentication. And if you want to use that, then this is the code right here. So you just say Google credentials, then you say get application default. If you want to use a service account instead, then you need to point to the key file that you can create for your service account. You can create a JSON file for your service account. Then you have to point to that wherever you have that. It could be added as a file on disk. It could also be in the resource folder. You just need to point to the Google credentials class so it knows where it is. And so instead of using default credentials, then you could use that. It's quite simple. So yeah. Then you have to create scoped like this, and you have to add this URL right here. So it's cloud platform. Refresh access token, and then get the token value as the last thing. It is not difficult, but you just it's kind of if you want a token, then most of your programs will probably have this piece of code right here. There are some of the other libraries that say that you want to connect to PubSub or something else like that. Then you add your credentials and you add maybe the path to your JSON file. You add that either with environment variables or with the Spring Boot properties. But in this situation right here, I just want the access token. That's the only thing I want, and then I want to use pure REST to actually use the classifier. So, and that is now the next thing. So the first line right here was to get the access token, step 1, and then the second part was then, okay, of course we have to create the headers. Here I said bearer and I said access token. I said that the content type should be application JSON, and here I create my request. I use REST templates. So I use request entity right here, and then we have that is the URL, and the URL is up here. So the URL, you will get that from your endpoint. So you just go to your Vertex AI, and then you find your endpoint, and you say, hey, copy the endpoint URL right there. You can also take it from the sample request that you just saw before. There you will also find this URL right here. Then you need to add the project ID. Again, these values right here will be shown in your sample. So when if you go to the Google Cloud and you press please show me the sample request, then you will get all of these values right here, all of these in here in the top. So again, it is convenient. And of course, these values right here, you could have them as environment variables or as configured properties in your application.properties file instead of hard-coded like I have right here. Okay, so then you need to find a file. So what we want to do when you want to predict something, then you have something, and then you want to predict something about that something that you have. In this situation, it's an image, it's a picture. So that means that this is a byte, a string representation, and that means the byte representation of the JSON file, and it's UTF-8. That is what is expected right here. And of course, I could have actually accepted the bytes instead, and then I could have converted it to string right here. It might have been nicer instead of this, but okay. But that doesn't matter. That doesn't matter. This because this one works, and when I say that it works, how can I actually see that? Of course, with a unit test or Spring Boot test. I have my classifier service right here, which is I'm wiring in, and in this situation right here, I take all of the bytes from this file right here, input data rock JSON. Let us just look at that file just for a minute, just to see what actually happens. Input data rock.json right here. So this is the JSON file that I have. That means that we actually I've already converted the. Yeah, so actually the string that we are posting right here is actually a JSON. It is a JSON string. I was wrong with what I just said there. It's not the byte representation of the image. This is JSON, and inside this JSON that we are posting, then we have the base 64 encoded and byte representation of that image right there. So this is that representation right there. In the other videos, I showed you how to actually create this file right here. If you want to do it manually, then you can go, and there's something called that's a byte conversion site where you can just upload your image, and then you get this interpretation of the image instead. Of course, you could also do this programmatically, and then your code will be slightly more complex, not much, not a lot, and of course, then you would have to build up an object that represents this structure that we have right here. You need to have an instances and an array in there. Then you would have a content, which is the file base 64 encoded byte values. So let us go down the bottom. And after that, when you're done with that, then you need to add some parameters right here, and those parameters will say which confidences do you want. So this here we have a confidence threshold of 0.01, and that is that's a bit low. We only want prediction when the model is more than 50% sure that is the correct label. So so let us try to run the test actually. So what it does is it takes that JSON file, and then we use that in our classifier right here, and then we print out the results. So quite simple tests. I don't know if it's simple or not, but there are not that many lines in it, and that is of course because we have hidden away all of the complexity in our service. All of the cool stuff happens right here. So let's see what happens now. So first we got the token. And then the second part was that we loaded the file, and then I print out the file right here. That was because I was not sure that I had the correct content to begin with. We don't need to print out the file. I think we know how to read from a resource stream. And then we get the result here in the bottom. So here we have the result right here. And I also get some output that it's the default authentication and default credentials that I'm using right now. I could use a service account instead. Here we have the predictions right here. So we have a confidence of 92%. You have to multiply this with 100 if you want it in percent. So this 93% is 93% sure that the image is actually a rock. And I know that it's a rock. I don't know if I can show it to you actually. And I probably have to open up another project, the project that we used last time. But I guess that is no problem either. So we have this rock right here. It was it was rock 2, this one. So it was this picture right here that was converted into a base 64 representation of the encoding of the bytes of the bytecodes. So so the display here we see the display names, the confidences, and the display names right here. Rock, so it should be a rock. And that's actually then there's some metadata about which model was used and called, and this is version 1. So that is fine. It's nice to get that receipt. Now let us try to change the rock data a little bit, because we saw that we have a confidence threshold of 0.5. Let us set this to 0.1 instead, just to begin. Let's see if it gives us any difference or any changes. So now we get, maybe we will see that now it could, let us just check it out in the bottom right here. We get still a rock. Of course it needs to be a bit lower than that, 0.01, because we have one that is 93%, so of course there's only 7% left for the rest of the labels. So let us just check what it says now. So now we should get some more labels and some more. See here, now we know we still get 93% chance of it being a rock, so that is the same place as this confidence right here. Then it is actually, there are actually 4% chance that this is grass. And that actually makes sense, because if we look at the image right here, then there are also a lot of grass on this image right here. The reason why it says it's a rock, that's because we have trained it to actually see different rocks on a grassy background, and then still classify it as a rock. And that is a cool thing. That is a strong thing about image classifiers, that you can train them to label images in a certain way that you need for your use case, even though that this is both grass and rock. In this use case that I had, it was a made-up one, so then I wanted this to be a rock, so I knew where to go and remove these rocks, so I could cut the grass better or something like that. Yeah. So in this use case, I wanted to be a rock, even though there's also grass on it. Then we have the mark rate. There's actually 2% chance of it being a picture of a mark rate, and that is not true. It's probably maybe some of the white here that confuses it a bit, but it has also, the confidence is very, very low. So it is. I'm quite happy with my model and my trained version of the model. 93%. It's a rock, and that's awesome, right? So that is actually it. We also have the dandelion. Actually, should we also run that one? Let us just do that. So I'll just copy this, duplicate this code right here. And then we say dandelion test. We're not printing out this one right here. Then we say input data dandelion. Wasn't that the name of the file? Dandelion. Yes, it was. Okay, so let us try the dandelion. Let's see how it classifies that one. I'm going to delete my model and my endpoint after this video, because input data dandelion. Misspelled it, of course. I'm going to delete the endpoint afterwards, because it's simply too expensive to have them running when there's no value in the other end to harvest for me. It was just to make a demo. So here, okay, so in this situation we have 83% chance that this is a dandelion. That is, of course, it's quite high. That's quite good, but not as good as the rock, of course. Of course, in this situation, maybe I could go out and take more pictures. You should actually have, best practice is 1,000 images per label. Yeah, I think this is quite close actually still. So we have 83% chance that it is a dandelion. Then we have 9% chance that it is grass, which kind of also makes sense, because if I look at the image right there, right, where is the dandelion image? Then there's also grass in the image. I actually forgot it. It's one of these three right here that I took. I think it was this one right here, just to test it. So I just found an image, yeah, and there's also grass in that image. So yeah, so that was just my point. But it's a lot of fun to sit and play with these things right here. You just need to be careful with the billing. Yeah, it can cost a lot suddenly, and just don't let it surprise you. Look at the billing maybe every hour when you start playing with it, and then turn off all of the workbenches and whatever you have running that when you don't need it anymore. I'm definitely going to go to online predictions right now, and then I will say I cannot delete it because I have a model under it, so I'll just press right here. Then I'll say undeploy, and here I can also see here we get some performance metrics for how it went. Undeploy model from endpoint. Yes, please undeploy my model. Then I can go to my endpoint, and then we can say delete endpoint. Thank you very much. Hopefully that will stop the delete model. I don't need. Should I delete it? It depends on how much it will actually cost. I should not. I think as long as I don't deploy it, then I'm not charged anything. I would actually like to leave it, because it takes 1.5 hours to train it with my images. So I think I will leave this one right here. If you I think a bit later on, then I will dig into the pipelines, because the Vertex pipelines are quite awesome. Because let's say that now I go out and then I take some more images, I take some more pictures of dandelions and rocks and grass. Then if I have a pipeline, then I could actually create a pipeline that actually then retrain the model and then create a new version, maybe version 2. And then I could actually look at the confusion matrix. You could look at the confusion matrix, and then I could actually see if and I could also look at these metrics right here. If let's say that the precision is higher than and also the recall precision, if those percentages are higher than the version 1, then it could actually automatically deploy the new version instead. That is the kind of things you can do with the pipelines. But I'll make another video on that one. It's quite simple, it's quite awesome as usual. You will just annotate some Python functions with component or pipeline, and then you have your pipeline. But that is another story. I am grateful for your attention as always, and thank you very much for all of your comments. They simply make my day every time. So thank you very much. Have a nice evening, and I hope to see you again soon. Bye bye.